All right, algebra class. We're going to talk about the last way of factoring today. I haven't looked at the quizzes yet, so I'm not sure what all the grades are and everything. I'll try to look at those tomorrow and Friday and get those in the grade book. But our last type of factoring is the special type of factoring, and this is called the difference of perfect squares. So, difference of perfect squares. Now, in order to understand the difference of perfect squares, you have to understand what a perfect square is first. So let's talk about what a perfect square is. A perfect square is not a shape, okay? A perfect square is a number that has been squared. So let's talk about some numbers that have been squared. 1 squared is 1. 2 squared, 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169, and so on. Perfect squares are numbers that have been squared. Difference. When we're talking about the word difference in math, what are we talking about? We're talking about subtraction. So when I'm looking at the difference of perfect squares, it will be a problem that is subtraction, and both of the terms will be different, will be perfect squares. So one of these numbers. Before we get into one of these problems, let's first look at something that we've done before, okay? So we've been checking our answers on some of these factorings that we've been doing, and we were doing that with our favorite method. So most of you all chose double distribute. So like if I asked you all to double distribute this, okay, x plus 4 and x minus 4. So double distribute, so x times x is x squared. X times negative 4 is negative 4x. Positive 4 times x is positive 4x, and 4 times negative 4 is negative 16. And then you all would combine like terms in the middle. So negative 4x plus 4x, negative 4 plus 4 is 0, and you got x squared minus 16. This right here is difference, and these are both perfect squares. So this is a difference of perfect squares, and these are what we're going to be looking for. Okay, now we were talking about perfect squares, are numbers that have been squared. So 2 squared is 4, 4 is a perfect square. 3 squared is 9, 9 is a perfect square. What is the opposite of squaring? Square rooting. So the square root of x squared, you're thinking what number times itself makes x squared? Well, x times x makes x squared. 16. What number times itself makes 16? What is the square root of 16? 4 and 4. And that's where that comes from. This is difference, and these are perfect squares. And difference of perfect squares are special because, look, they only have 2 terms, whereas all the other problems that you've been factoring have 3 terms. An x squared, an x, and a number. Difference of perfect squares just have 2 terms. So let's look at some examples. Okay, so how about x squared minus 144? So right off the bat, you should notice that this one looks different, and the directions are just going to be what they have been factor, okay? So we're checking. Is it in standard form? X squared number, 2, yes, it is in standard form. Is there a greatest common factor? 1 and 144. No, there's no greatest common factor between 1 and 144. So now I'm ready to factor. So I notice it's special because it only has 2 terms. I also notice that this is a subtraction, so it's difference. And then I need to ask myself, are these perfect squares? X squared is x times x, so yes, it's a perfect square. And is 144 a perfect square? What's the square root of 144? 12. So my factors will be x plus 12 and x minus 12. And they have to be different signs because if you were to multiply those back out, that middle term cancels out, and that's what makes it special, is because the factors are exactly the same. One's a plus and one's a minus. Okay, let's do another one. Oops, I wrote that wrong. Just kidding. All right, 4b squared minus 121. So I'm looking at it. Is it in standard form? B squared, 0. So highest to lowest exponent, yes. Is there a GCF, a greatest common factor between 4 and 121? So 4 is 2 times 2, 1 times 4. 121 divided by 4 is a decimal. 121 divided by 2 is a decimal. So that's it. There is no GCF here. So then I'm going to ask myself, is this special? Is this difference? Yes, because it's subtraction. Is 4 a perfect square? 2 times 2 is 4, so yes. B squared? Yes, B times B. 121. What's the square root of 121? 11. 11 times 11 makes 121. So my factors are the same. They're opposite signs. The square root of 4 is 2. The square root of B squared is B, so 2B. And the square root of 121 is 11. And that would be it. If you don't believe me, check them. Multiply them back together. It will match up to this. Let's see. Let's do this one. This one's got 2 variables in it. So 16h squared minus 9a squared. All right. So standard form. Squared, squared. It's in standard form. That's all it can be, is because they're both have a highest exponent of 2. All right. GCF, 16 and 9. Is there a greatest common factor of 16 and 9? No. All right, and then I'm going to look at it. It's special because it's 2 terms. Is it difference? Yes, because it's subtraction. 16 a perfect square? Yeah, 4 times 4 is 16. What about 9? 3 times 3 is 9. H squared and A squared, they've got squares on them, so they're a perfect square. So the factors are the same. They're just opposite signs. And the perfect squares, I take the opposite. I square root. So the square root of 16 is 4. The square root of h squared is h. So that'll be 4h and 4h. The square root of 9 is 3. So 3. Square root of a squared is a. So 3a and 3a. All right, let's do another one. All right, so 5x squared minus 20. So looking at it, it's in standard form, squared number, so that's good. Then I look for a GCF, 5 and 20. Is there a greatest common factor of 5 and 20? 5. I'm going to take out a 5 as a greatest common factor first. So 5 divided by 5 is just 1, so that's just 1x squared. Negative 20 divided by 5 is negative 4. And then remember, just like when we had ones with GCF, then you factor what's in the parentheses. So right here, I'm going to factor this. So it's still looking special because it's only 2 terms. So is it difference? Yeah. Is x squared a perfect square? Yeah, because it's squared. 4. 2 times 2 is 4. So my factors are x plus 2 and x minus 2. And I know that I usually have questions in class, like, does it matter if you put the plus here and the minus there, or the minus here and the plus there? It doesn't. Doesn't matter which order you put them in. All right, we're going to try a couple more, and then you'll work on your homework today. Let's see. So why don't you all pause the video after I write these 2 up here, and then I will work them back out. So pause it here. All right, so standard form, GCF, nope. Difference, yes. Perfect square, yes. Perfect square, square root of 64 is 8. So that'll be y plus 8 and y minus 8. The next one, standard form, x squared number, yes. Is there a greatest common factor? Yes. 27 and 75 have a greatest common factor of 3. So 27 divided by 3 is 9. 75 divided by 3 is 25. And then it's still special because it's only got 2 terms. So is it difference? Yes. Is 9 a perfect square? Yes. Is 25 a perfect square? Yes. So I'm going to factor it. The square root of 9 is 3. The square root of x squared is x. The square root of 25 is 5. So 3x plus 5 and 3x minus 5. And don't forget your GCF of 3. So hopefully you all understand. This was the last part of factoring quadratics that we're going to learn. And next week we'll do a little bit more practice. and then we will move on to the next concept that we need to know. These skills are super important for Algebra 2. I'm going to expect you to know them right off the bat when we start Algebra 2 next year. And if you don't, you're going to struggle a lot. So make sure you're actually doing this, taking some notes, so that you can look back at them for homework and things. All right, bye.